Okay, I've 3D printed some parts for the Rudy 2.5 version, and thought I'd talk about them before things got assembled and maybe too confusing in case any of you want to build a version of it. But basically, the arm that we talked about in the CAD design, there's the arm, lever, and link, and this can move. Just tighten the screw until it's a nice friction fit. That way you can adjust the arm movement. And of course there's a right and a left arm. Got those there. The head, which normally is going to look like this. Of course it's two parts because I need room. I'm thinking for my flashing LEDs in the front, I need to change that 1.5 volt battery up to 5 volts. So I need room to stick in the voltage the converter to boost the voltage up and regulate it. And easiest way to print it is going to be like that, as far as how much support material is going to have to be added. The feet, they're both identical, and of course you make two of them. And here I've already glued the 3 toes on. Again, being this small, it doesn't need the 3 toes, but the original toy had 3 toes, so I gave mine the 3 toe action. If your printer does the elephant's foot, you know, where it spreads out near the base, you're going to need to file or sand this down, because this prints like that. And to get rid of that elephant's foot, because when this is inside the toy, this is going to run between 2 pivot points, and that elephant's foot would make it wider and things will bind up. And if things bind up, they're not going to work. Alright. The body front prints flat, so there is lots of support material that you remove on the inside. Here I've already glued in the 3 flashing LEDs, and I'm using a 330 ohm resistor as my current limiting resistor because I don't want them drawing too much current off the battery boost circuit. I just want enough to see the light effect, so they'll shine through there. One thing that I've changed after I printed this is these are the support places where the legs, like I talked about, when these are in there, they kind of rest up on that. It's a pivot point. Yanking the support material out, I managed to break one of these off, which of course I glued back in because I didn't want to lose 4.5 hours printing time. So to make these stronger, I have added material from here up to the body, so there'll be a whole lot of material there, less chance that you're going to break those off when you're pulling all the support material out. The back, I've already mounted in the AA battery holder and the switch, and the wire from the bottom just routes up the side here. Everything comes out the top. The switch, you can just interrupt one of the battery wires. I interrupted the positive, the red wire, to turn everything on and off. And if you're not going to go fancy with the forward reverse switch like I'm planning on doing, you can just connect these right up to the motor and you're done. You don't have to put the LEDs in. You don't have to use a voltage boost circuit. You can go real simple. Just interrupt one of the battery wires, connect it to the motor, turn your robot on and off. You can go real basic. So I have my red and my black wire. This is my 1.5 volt battery power. Then these 2 purple wires that are sitting here, they just route down the edge, and then there's a hole back here, and they're coming through. And the method that I'm using on this one, I've tried 3 different methods in designing a switch. See, this robot being so small, it doesn't have a lot of mass, and it's a slow walking one. There's not enough room to build in a snap action double pole double throw switch. That's 6 contacts altogether. You almost want it frictionless. The great big huge Rudy has so much mass and walks faster. They didn't have any problem designing their own double pole double throw switch, although it's the main thing that goes wrong with the toy. But in this case, I just need a single pole switch. I want something that closes when the robot walks into something. I want a switch that closes. I want it to stay closed until it backs up into something, and then I want it to open up. So what I'm going to do is I have a tin plate here, tin so that it's magnetic. In this particular one, I inserted a brass tube into this hole, and you can almost see that see that brass, and soldered a wire to that too. So basically, if you connected this tube to this wire, you would have a closed circuit. To close that circuit, this is the 2.5 millimeter rod that I decided to use. This is the magnetic switch piece. This particular one is an earlier version. I have since added, as you saw in the CAD files, I've added a little dip down place for this piece of tin to fold over and fit in so it's flush and doesn't stick above. This one I just melted down in with a soldering gun to get it so it doesn't stick up above. You can solder a wire off that, and I'm going to run the wire over and solder it right onto this shaft that's going to move. Now, I have also tested just taking a wire off here, because there is room in the front half of the body shell to bring that wire up and then bring it through and make my switch that way. But the problem with that is, unless you use a really, really small wire, diameter wire, gauge wire, the wire is going to act like a spring, and it's going to either make it want to stay closed all the time or make it want to stay open all the time. So I decided this way, this metal rod is this wire, comes to here, becomes this contact, then you've got this contact, and there's a hole on each side, just like that hole there. There's one behind here too. And in there, I've put in 2 of the 1x3 millimeter magnets. Small little guys. I think I've got some here. Here's some of the brass tube that I inserted into the body part. Here's a piece of tin. You can just get this at hobby stores or wherever. And there's actually 2 stacked one on top of the other of the 1x3 millimeter magnets. And I found that if I use 2 of them, by the time it goes through this piece of metal, then it just barely sticks to that one. And that's all I wanted. What I wanted is when this bumps into something, I want to make sure that switch wants to stay closed and doesn't want to vibrate open or jitter or anything else until the back thing pushes, till the robot walks up and bumps something. Then I want it to stay open. So I just wanted just a little bit of magnetic. So that's going to give me basically a nice frictionless switch, I believe. And then I'm going to put some electronics up in the head that we're going to talk about that's going to change this single pole switch into the double pole switch that we need. What else? On the ends of these bars, there's the little bumpers, for example. That little bumper will go there, and of course there'll be one on the back as well. The motor unit, like I say, it's a standard TTT gear motor, the 48:1, or as I like to call them, 1:48 gear ratio. And I've got the 2 cams on, which I showed in the CAD drawings. The big lobe is for the legs and the little lobe is for the arms. So for example, the legs would be riding on this big lobe, like a so. So one thing you need to make sure is when you print these parts, where these legs are going to go up inside, you need to take a flat file, because there'd been support material in there, and just run that flat file along this side piece and along this side piece. This is the front, because you want to do the same thing to the back and smooth all that out. You want that real smooth, because if it's not, then these legs will bind up when they're sitting in there, and you don't want them binding up. And in fact, to make sure that nothing's binding up, I don't know if there's enough room for me to do this on camera. Basically what I'm doing is I'm putting the 2 legs on the 2 cams, and I'm going to drop the motor into place so you can kind of visualize what I've been talking about. These legs are going to go all the way back till they rest on those two posts. When the front's on, the front has those two posts that come up. Now you don't want those to pinch too tightly. If they pinch tightly, it's going to bind everything up. The robot's not going to walk. So I already soldered 2 wires off the motor. They're now sticking up. So what I'm suggesting you do if you want to build this is go ahead and connect those 2 motor wires to your red and your black battery wires to run it with the front on and in place. Nothing else in there yet, because that way you can see if anything's binding up, and if anything is binding up, you can come back in with a flat file and hit the tops of these in both sections. I just went in like this, just ran it around a few times and cleaned those off till things are just a hair of slop, you know, like the thickness of a piece of paper slop. You don't want it tight, because if it binds up, it's not going to walk. So that's where we're at right now. If you want to, the next video I'll actually get into, I guess, having it more assembled. If you want to see basically what the arm does, is you've got that smaller pin we talked about, and the arm has its linkage, so you can see how this just is going to get it in the camera so it shows something. Just like that. Both sides are going to be the same way, but the one over here, but I'm holding everything together with my thumb right now. So I guess in the next video I'll talk more about the electronics that I'm going to use. Again, you can build a real simple one where you just turn the motor on, don't have to do anything else. But that wasn't my objective. I wanted to actually emulate the forward and backward walking of the giant Rudy when it bumps into things mechanically. So I'm going to show you what I've come up with, or the different ways that I've come up with that seem to work okay.